a functions question or a modelling question, and we're told that the function is f of x equals 3x minus 1 plus 4x to the minus 2, and it's shown on the diagram. So it's defined for all values of x except for a, and we need to find what this value of a is. What that means is, where is the asymptote? Which of the parts of the domain is it not possible to plot? So where is it not defined? Now, if we look at this function, we know that we could rewrite this as 3x minus 1 plus, and if it's a negative power, that's the same as writing it underneath. Now, we know that there can never be a denominator equal to 0, and when the denominator is equal to 0, it's an asymptote, and that means a equals 0. If 0 is the value of x, that denominator would equal to 0, which would not be possible. And then for part B, we need to use the calculator to find the coordinates of the local minimum. So nice and easy here, these are 3 marks. It's just to graph this in the calculator. So 3x minus 1 plus, and then it's a fraction, 4 over x cubed, x to the power of negative 2. And if you wanted to, you could just write it, And if you wanted to, you could just write this as 4x to the minus 2, the same as it gave you in the exam question. Either would be totally fine. So if we graph this, we need to change the window to what we're looking at on our exam paper, which is -4 to 6, and then -8 through to 14. So we're trying to find the minimum point, which is this point here. So trace minimum point, and it's somewhere between these values. And we can see there that it's 1.39 to 3 significant figures, and then 5.24. So if I go back to my exam paper, then I can write that on. So we have 1.39, 5.24. And then it says that the equation f of x equals w, so this is like y equals something, has 3 solutions, and identify the possible values. So we know that a y equals line goes horizontally across my page. So it's saying what value of y, as I move this up and down my graph, is going to give me 3 solutions. So for example, just here, I know that I only have 1 solution. If I move it up to here, I still only have 1 solution. If I moved it up to here, I now have 3 solutions, 1, 2, 3. And at this specific kind of minimum point, I know that I have 2 solutions. So it's more than 2 or 3 solutions, which is what I'm after, for any value bigger than the y value of the minimum point, which is 5.24. So it's any value bigger than 5.24 up to the top of the graph, which is 14. So you can write any value at all there, so anything between 5.24 and 14. So let's, on this one, move it to 8, for example, and then we can see that we have those kind of 3 solutions. And we're told that the line of y equals mx minus 1/4 is a tangent to f of x. Now this tangent, this just means the same as you've done in other parts of maths. For example, if you have a circle, a tangent touches it exactly once and kind of follows that same line. And it's the same with a curve or an equation. A tangent just touches it exactly once. So if we have the line of y equals m of x minus 1/4, and it's the tangent when x equals -4. So x equals -4 here. So somewhere, if I continue this graph here, my tangent is going to be positive. We can see there it's a positive gradient, and therefore all we're interested in is writing down positive or negative and giving a reason. And just even explaining that the drawing is on the graph there would be enough. But we can see that the function is increasing at that point, and therefore it's a positive gradient. So moving on to the next part of the question, it now becomes more of a modelling question where we have this exponential model that we're going to be using. So we're told that we have p to the power of x minus 9, and it goes through 2 points, a, which is 0 minus 5, and b, which is 3, 4.5. And we're trying to find k and p, so we can do that by using those two coordinates to help us find the answer. So if I do this down here, we can see that when using coordinate A, when y equals minus 5, x is equal to 0. So that's just using those two parts of my coordinate. So the equation is g of x, or y, so minus 5, equals k, and then I have power of 0 minus 9. And then we can use the other coordinate as well. So this is coordinate b, which tells us that when y is equal to 4.5, x is equal to 3. So for this one, we have 4.5 equals 4p cubed minus 9. And then from that, we can find both p and q. So anything to the power of 0 we know is equal to 1. So this gives minus 5 equals k times 1 minus 9. So we can use numeric solve there and find that k is equal to 4. And then for the second one, we now know that k is equal to 4. And then you can substitute that in and find p is equal to 1.5. Okay, so that's where the 4 came from there. So that's the first part of the question. And now we can write down the equation of the horizontal asymptote. So the best thing to do there is just to graph the equation. But equally, we know that the horizontal asymptote of any exponential function, so let's write the final equation. So g of x is equal to k, which we've now found to be 4, and then p, which is 1.5, to the power of x minus 9. And we know that the asymptote of any exponential function like that is the last part here, and therefore the asymptote is just y equals negative 9. And then for part G, we need to find the solution of f of x equals g of x. So for this one, we already have the f of x plotted, and now we're going to plot the g of x that we just found. So 1.5 to the power of x, power button, it's there, minus 9. And we have the two plotted together, and we're finding the solution of when they're equal. And there's two solutions there, one down here and one up here. But it does say in the exam question that it only wants when x is bigger than 0. So it's trying to catch you out here. Don't put the wrong one on, or don't put 2 if there's actually only one solution. So the intersection that it's after is this one up here, and that's when x is equal to 4. So I can go back to my exam paper, and we can write down that it's when x is equal to 4, and we know not to include the other value. And then we consider a third function h, where h of x equals f of x plus g of x. c minus 1q lies on the line, and we need to say whether c also lies on h of x or not. Now, if it's the x value here is negative 1, if we go back to the original, when x is negative 1, this first function f of x is actually equal to 0. So that means that the f of x part is 0. So h of x, or h of minus 1, let's write that as, so h of minus 1 is equal to f of minus 1 plus g of minus 1. Since f of minus 1 is just equal to 0, yes, h of minus 1 does lie on g of minus 1 because they're equal to each other. So yes, they are, and it's because of the fact that f of x is just 0. So for that one, you need a justification as well as your final answer.